On August 7, 2025, at a defense industry event in Huntsville, Alabama, Lieutenant General Robert Rash, Director of the U.S. Army's Rapid Capabilities and Critical Technologies Office, RCCTO, confirmed that the service is preparing to restart a bold and technically complex project, an artillery-based air defense system centered on a hypervelocity cannon. Rash explained that his office is finalizing requirements and shaping an acquisition strategy, but the program's future ultimately depends on congressional approval of funding in the fiscal year 2026 defense budget. If lawmakers provide the necessary resources, the Army hopes to relaunch the program quickly, aiming to field the first operational battery by 2029. Such a system, capable of firing projectiles at extreme speeds to counter incoming missiles or drones, would represent both a continuation of past efforts and a step into a highly competitive field of emerging global military technologies. The idea of using artillery to achieve missile defense effects is not entirely new. The origins of the hypervelocity cannon trace back to the U.S. Navy's experiments with the hypervelocity projectile, HVP, developed by BAE Systems. Initially envisioned for use with naval railguns and conventional deck guns, the HVP promised high-speed intercept capability against cruise missiles and aircraft. But by 2021, the Navy's program had stalled, hampered by funding cuts and questions about feasibility. The Pentagon's Strategic Capabilities Office, SCO, later revived the concept under the Multi-Domain Artillery Cannon System Initiative. SCO's version paired a 155mm self-propelled howitzer with hypervelocity shells, giving a traditional artillery piece new capabilities as both a long-range strike weapon and a defensive tool. Now, with responsibility shifted to the Army, the effort has been rebranded as the Cannon-Based Air Defense (CBAD) program. Rash noted that the Army is carefully reassessing every component of the SCO's earlier work. That includes the 155mm cannon itself, the radar systems required to detect and track targets, the battle management software, resupply mechanisms, and the advanced projectile. Each of these technologies is at a different stage of maturity, meaning some could be competitively bid while others may need to be awarded directly to a single supplier. This nuance is important because it reopens the question of industrial participation. At the end of 2024, BAE Systems had been widely expected to secure exclusive contracts for the cannon and projectile. Now, however, the Army is signaling that those awards are not locked in. By leaving room for additional suppliers, the service could both broaden its industrial base and potentially drive down costs, though at the risk of slowing development. The U.S. decision to reconsider hypervelocity artillery does not occur in a vacuum. Around the world, several major powers are pursuing their own experiments with high-speed, long-range, or electromagnetic weapons. China has heavily invested in electromagnetic systems and long-range artillery that incorporate hypervelocity trajectories. Open-source reports suggest that Beijing has tested shipborne electromagnetic cannons, though analysts debate how close these systems are to operational service. Regardless of maturity, the emphasis demonstrates China's intent to field disruptive technologies capable of countering U.S. missile defenses and extending its own strike capabilities. Russia, by contrast, has placed more emphasis on evolving existing artillery designs. Programs such as the Koalitsiya SV self-propelled howitzer represent incremental but significant improvements in range, automation, and fire rate. At the same time, Western assessments regularly cite Russian interest in high-velocity projectiles, which could provide their forces with new means to penetrate defensive systems. Europe has been more cautious. While the European Defence Agency has funded research into guided shells and electromagnetic propulsion, most European programs focus on improving conventional artillery effectiveness rather than pursuing the extreme velocities sought by the United States. The Franco-German Common Indirect Fire System, CIFS, for example, is intended to extend the range and accuracy of 155mm guns but stops short of aiming for hypervelocity thresholds. For Washington, these developments mean that falling behind could prove strategically costly. The revival of the cannon program is therefore both a defensive necessity and a way of keeping pace in the broader race for technological superiority. One of the most significant unresolved questions is whether the hypervelocity cannon should remain a strictly defensive asset or be expanded into a dual-purpose system. While its primary mission is intercepting missiles, drones, and other aerial threats, the underlying 155mm platform is inherently capable of offensive fires. If the Army chooses to design the system to fire both hypervelocity rounds and conventional artillery shells, the implications would be considerable. Such flexibility could transform it into a cornerstone of future fire doctrine, capable of both protecting forward-deployed forces and striking targets deep behind enemy lines. Yet this versatility would also bring logistical complexity and new demands for training, doctrine development, and sustainment planning. The Army's reassessment is not limited to the cannon itself. Rash confirmed that earlier phases of the project had looked at integrating autonomy features, such as leader-follower resupply vehicles. These technologies would allow robotic platforms to deliver ammunition and supplies with minimal human intervention, reducing risk to soldiers operating in high-threat environments. Similarly, battle management systems are being designed to integrate seamlessly with the Army's wider air defense architecture, linking sensors, shooters, and decision-making tools in real time. This networked approach reflects the growing importance of multi-domain operations, where the boundaries between artillery, air defense, and missile defense increasingly blur. Despite the clear enthusiasm within RCCTO, the path forward is far from guaranteed. Rash emphasized that the acquisition strategy remains deliberately flexible, with several options presented to Army leadership. The service wants to avoid locking itself into a single industrial solution or rigid timeline too early. The real gatekeeper will be Congress. Without approval of the FY 2026 budget, the hypervelocity cannon will remain little more than a promising concept. If funding does materialize, however, the Army intends to accelerate development quickly, aiming to deliver an operational capability within 4 years of program restart. At stake is not only a new weapons system but also a potential shift in how the United States approaches both air defense and artillery. A successful hypervelocity cannon could reduce reliance on expensive interceptor missiles by offering a cheaper, gun-based alternative for some defensive tasks. It could also restore the Army's long-range strike relevance in environments where adversaries are deploying advanced missile and drone swarms. Internationally, Washington's trajectory could shape how rivals pursue their own research. If the U.S. demonstrates credible progress, it may push adversaries to accelerate or diversify their efforts in electromagnetic and projectile technologies. Conversely, if the program falters, others may feel emboldened to claim technological leadership in an area long dominated by American innovation. The hypervelocity cannon is, at its core, a bet on speed, both in technological terms and in acquisition strategy. It represents an attempt to build upon earlier work by the Navy and SCO while responding to the accelerating pace of global military innovation. For the Army, it is a chance to reshape the balance between artillery and air defense, potentially redefining tactical fires for a generation. Whether this vision becomes reality depends on congressional funding, industrial cooperation, and the Army's ability to manage risk without stifling innovation. By 2029, the United States may either field a revolutionary weapon or once again shelve the idea of hypervelocity artillery. The outcome will help determine not only the Army's future capabilities but also America's standing in the international competition for dominance in advanced firepower.